So we're starting back with unit 2.1, where it was arithmetic or geometric. So if you remember, arithmetic was adding or subtracting, and geometric was multiplying. So what do we have to do here? State whether it's arithmetic, geometric, or neither. Write the first two terms afterwards. Write an equation for the sequence, and find the term value of that term after the dots, after the ellipses. So 27 to 36 is adding 9. 36 to 48 is adding 8. So that's not constant, so it's not geometric. So let's see, what would our ratio be on this one? So to find our ratio, we take any term divided by the previous term. Okay. So 36 divided by 27 is 1/3. Okay, so let's see if that gives us our next term. So we need to get 48. So that, so our ratio times 36, well, that gives us 48, because again, 27 times 4/3, and then we do 36 times 4/3. So there's our ratio right there. So to write our rule, so we know that this is geometric. So let's find our next two terms. So 48 times 4/3, 64 times 4/3 again. So 64 and 85.3. So write an equation. So any term, let's say if we use our first term, times 4/3 to the n minus 1. And a reminder, we can start with any term. So if I would have started with 36, it would be times 4/3, but that's the second term, n minus 2. If I started with 48, 4/3 times n minus 3, that third term. So again, as long as this term matches, we subtract that term number. And now it says find the term value of this. So I want to find, when does 849,490.0219 equal 27 times 4/3 to the n minus 1? Well, first thing I got to do, I got to divide by 27. So let's see here. I wish I had the other calculator to show you, but I don't have that on the iPad, so I'll just have to use Desmos here. So we have 849,490.0219 divided by 27. So 31462.59. $31462.59. And now what do we have to do? We have to log base 4/3. Because again, then we just have n minus 1 on this side. So to get the log key on here, I go to functions. That doesn't have the base. I need to choose the one that has the base. There we go. 4/3. 31462.59. 340. Oops, and I forgot the point. This is 0.593437. 35.99, so 36. So that means it has to be the 37th term. All right, well, I can look at this one and I can say it's not arithmetic, so I'm going to see what that ratio would be. So negative 45 divided by 50, and let's see if that works. So our ratio is negative 0.9. So 50 times negative 0.9. So 45 times negative 0.9. Okay, that seems to work. So 40.5 times negative 0.9. Negative 36.45 times negative 0.9. So we have negative 36.45. And then it was 32 point something. 805. So that means this is geometric. So let's see. So if I start with 50 times negative 0.9 to the n minus 1. So now we want to find this term. So negative 15.6905. 50 times negative 0.9 to the n minus 1. So let's divide by 50. So we have a negative 15.6905 divided by 50. So negative 3139 equals negative 0.9 to the n minus 1. And now here's the tricky part. We can't do a net log with a negative 0.9. So this might be one where we just have to keep multiplying by that 0.9 because we can't solve it with that log. So negative 50 times negative 0.9. So there's our second term times negative 0.9, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 12th term. There we go. So it's the 12th term. So again, and we can't do that because that negative 0.9 and we can't have a negative base. So let's see, what is this one? Plus 6, plus 8, plus 10, plus 12. So it's not arithmetic. And let's see, 10 over 4. Let's see if that works for, or it's not arithmetic. So 10 divided by 4. So times 2.5. So 4 times 2.5. Times 2.5. So it's not geometric, so this one happens to be neither. And let's see, so this is plus 14, plus 16. So our next one would be plus 18. So we have 88. And then it would be plus 20. So we would have 108. And then I'll tell you what, since this goes so far out, we don't have to keep finding that next term because we haven't talked about how to do that yet. Now this last one. So we go to x to 2x to 3x. So we're adding x's, right? And then let's see what happens here. Then it's minus 0, minus 1a, minus 2a. So our next term would be 4x minus 3a, 5x minus 4a. So we're adding an x minus a. So we start with x, and we're adding, let me see. So any term, we start with x, and we add x minus a, n minus 1 times. So one thing I noticed there, this is our first term, second term. So what term is that? That has to be the 240th, and I wouldn't even need to use the formula. So the second one here, determine if it's arithmetic, geometric, or neither. Find a linear function that models. For those that are geometric, find a geometric. Well, let's see. Plus 3 plus 6, nope. Times 2 times 2, well, that's not times 2, so this one has to be neither. This one plus 3 plus 3 plus 3. So it's arithmetic. And so what would this look like? Let's see, if we use our first term, so we could, or if we use 0, 5 plus 3 times n minus 0. Or again, you could use any, if you used 8 plus 3 times n minus 1, because it just has to correspond to that term number. How about this one? Times 4. So it's geometric. So let's see if I use our first term here. So 4 times 4 to the n minus 1. But again, you could use any term. I could use 16 times 4 to the n minus 2. Totally up to you what one you wanted to use. 2.3. Write an equation representing your salary after n years. So let's see. Our salary after n years. We start at 2,300 and an annual increase, so 1.08, and just to the n power, because that is our starting salary. So we don't even have to do n minus 1. What will it be in the 7th year? So I'm going to just leave this one. You guys could type this into your calculator and see what it is after the 7th year. So using law of exponents, rewrite the expression to describe the transformation that occurs from 3 to the x. So I have to rewrite this with the same base. So 3 times 3 to the x. Now when they're like this, what is our rule? Well, if I had x to the 3rd times x squared, x to the 5th, and I add them. So this would be 3 to the 2 plus x. So plus 2 means we go to the left 2. Well, what do we do here? Well, again, it's in the denominator, so to make it in the numerator, I flip it. So negative 1 times 3 to the x. Again, because a negative flips sides of what side of the fraction it's on. So this is 3 to the negative 1 plus x, so x minus 1. So this moves it to the right one. Well, what would this one be? 9 to the x. Well, this is 3 squared to the x power. Well, what is our rule for this? Well, let's see. So if I had x squared to the 3rd, x squared times x squared times x squared. So that's x to the 6th, we multiply. So this is 3 to the 2x. So this is a horizontal dilation. And again, it's horizontal because it's x times that. And horizontal, it's always 1 over the value, so of 1/2. All right, so this is 3 to the 3rd times 3 to the x. So that's 3 to the 3 plus x. So this is to the left 3. Which of the following is equivalent here? Okay, so 4 times 3 to the x. Well, let's see. This has a 2. So it can't be that one. So we still have to have that 4. So it's got to be one of these. And let's see. This one can be 4 times 6 squared to the x, right? So that's 4 times 36 to the x. So it's this last one. 5 times 3 to the 2x. Well, I know I can do 3 squared to the x power. So that would be 5 times 9 to the x. Let's see. How do I break this one up? Let's see. 9 times 4. Well, that's to the half times x. 4 to the half, that's the square root. So 9 times 2 to the x. And the function k is given by a squared times 4 to the x, where a is a positive constant. Which of the following is an equivalent form? Okay. So we have to have a squared. Well, so it still has to be one of those. And 16 and 2 is the difference. Well, 4 to the x. Well, 4 squared is 16, but this is the same as... Let's see, this could be 2 squared to the x, or 16 to the 1/2. Well, that's 16 to the half to the x, and that's the square root, so it's letter D. And let's take a look at 2.5. The following data represents all drivers by age who have stopped by the police for some reason within the past year. The median age represents the midpoint of the lower and upper limit of the age range. Plot on a graphing calculator. Okay, so what I want you guys to do is I want you guys to plot this on the calculator. I'm going to pause. If you guys aren't sure how to do this, you're going to have to go to the calculator help videos and watch that.